For lab 6, the first task was to create, was to split the dataset into training and test. So in task 2, this was already done. So for the task 2 is to create manual tuning. So for that, a Python script 6 lab6a.py is being created, and I'm going to take that over here. Okay, 6a.py. I have my script over here. Lab6a.py was created, and first, the necessary modules and libraries are being imported. After that, the reduced dataset is being read with the help of pandas library. So after it was read, from there, the first three columns um, the MD5 hash, then the label, and the target columns are being removed. So this is being performed for doing feature extraction. Then next, the target column is specified in the variable y. So after doing this, the data settings being split into test and train. And for doing this, we have imported train test split module. So here the test size is being given 0.33. And the next part, we are using feature selection method select kbest chi2. So these data frames x and y, we are passing it through select kbest feature selection method. So in the coordinates, we are giving both. Okay, so here select kbest chi2 method is being used. K is given 15. So 15 features will be selected, and coordinates are being given here. So this x1 um, contains the new contains the data after the feature selection method. So next, space is being defined. So here in space we have given different kernel values like a linear, poly, RPF, sigmoid. So 4 different values. And in C values we are giving the values which were specified like 100, 10, 1, 0, 0.1, 0.01. So next what I did is so we need to calculate the values for each scenario, cross validation, for where we need to print the cross validation score for each scenario. There are 4 different criteria specified here, and C values are 5. So 4 into 5, there will be total 20 scenarios. So after that, after that, I am printing the standard deviation and the mean of the cross validation score. So for performing this, I have used a for loop because I need to run all the scenarios. For that, I have used 2 for loops where each when I run this, I'm going to run this program. So for each scenario, it will show me the value different cross validation scores. Then it will show okay the kernel for a scenario. Let it run. Okay, so here it shows 10 different cross validation score. Then okay, it shows okay the kernel value here is RPF and the C value used is 0.1. Then it shows the cross validation score, then the standard deviation and mean deviation. So like this, here the value is kernel value is RPF, then the C value is 10, then the cross validation score is being printed, then the standard deviation which is 0.05, then the mean which is 0.84. Like this, 20 scenarios, it printed the scores for 20 different scenarios. And for the task 3, 2 scripts are being used, lab6b and lab6c. So for this, we are doing hyperparameter tuning using random search and grid search. So let me open lab6p.py. So here first the necessary modules and libraries are being imported. Then as I discussed for 6a, like the dataset or reduced dataset.csv file is being read. Then doing feature selection, like removing the first three columns and reading the rest, storing it into variable x. Then in the variable y, target column is specified. After that, the data set is being split into train and test. Test size is given 0.33, and like train size will be 1 minus 0.33. So next, select kbus chi2 method is being performed, is being used for feature selection. So here I'm use stratifield k fold for splitting the data into 10 folds. Okay. Then I have specified space. In space I have given different values, and I have given c value, and I have used log uniform, which was specified in the instruction, as specified in the instruction. These were given in an instruction like in total value. Then I used a randomized search, and have specified score equal to recall, cb equal to k4. So what I'm doing is like I'm using randomized search cv, and I'm going to print the best score and the best parameter. So I'm going to run this program. So first the features are being displayed. This is going to take some time. So this will run all the scenarios and will give the best parameter, like the best c value, the best kernel value. Like first it will show the best score, then it will show the best parameter like best c value, then the kernel value, etc. It takes a while to run. By the time it runs, then I can see lab6.6c dot. I can explain lab6c dot cval. So for this script, again the modules are being imported, and the only change that we are making is instead of randomized search cv, we are using grid search cv. So like splitting the, like extracting the feature, then specifying the target column, then doing splitting of data, then using feature selection methods like CHA2. Using static field, we are splitting the data into 10. Then in kernel, specifying the different kernel values like linear, poly, RPF, and sigmoid, and giving different C values. So here, when we are using grid search CV, we need to specify class weight. So here I've given balanced and none. Then scoring, I've given accuracy, and CV equal to K for I've specified. In search dot weight, I have specified the two coordinates x1 that we got after the feature selection method, and then y, which contains the target column. Okay, F6p. Okay, I think I ran the script, but it's still taking time. I will delete this and run it again. It's taking some time. I already ran and took screenshot for that. But okay, so when I run 6b.cy, I'm getting best score as well. The best parameter is like C with 0.0402 value, and kernel is equal to 12, and 12 value is 70.2611. So when I ran lab6c.py, like the best score I'm getting is 0.9531, and the best score is C with a value 10, and class weight is specified none. The kernel is poly. So let me take the script again. Take time. Next, task 4 is being performed where we do live classification and performance evaluation. So let me open the scripts. So for this, I have used the same script as that of lab 5. Okay, going to minimize this. Same script as that of lab 5, like a lab 5d2. Okay, first I ran the script lab 5d2. First, the modules are being imported, and the only change that I made was um, like in the SVC kernel, I have specified RPF, and C value I have given as 1.5. This is the only change that I'm doing to the script lab5d2.py, which was used for lab 5. And after running the script, I was able to get a file saved detector.pkl. Saved pk. Okay, yeah, I have my file over here. Then next, after getting this, I have run detector.py script on the samples directory. So now this is empty because when I ran detector.py script, it creates a detector.log files, like, so that gets empty. So this script was being provided, so I have given my path here and I ran the script. So when I ran the script, it will take all the like it will take files one by one and analyze it through kappa, and I get the detector.log, which contains the timestamp, MD5 hash, then the classification, like whether it's a bindingware or malware, and the probability. And this is in JSON format. So then for the third part, what we are doing is we are running lab5d3.py script for getting the ROC curve, like for plotting the graph. Like first the modules are being imported, then 3 lists are being created. Okay, and then we are checking like how the script works is like it first opens samples.csv file, and then it opens detector.log file, and it will check, okay, if the MD5 hash matches, then this will be returned to a list called contents, and it reads through samples.csv file, and if it contains a malware, then it is appended, like when it reads through and it finds malware, word malware there, then it will append one, and like this will be stored to y predict list. And if malware is not found, then what it does is it jumps to else statement and then like append it 0, like for pending word 0, and this will be saved to the list y prob. So after that, saving it to proper list, um, it is printing the metric classification report and the confusion matrix. And the next part, this code is for printing the ROC curve, like for plotting the graph. I already ran the script here. This was used for lab 5 too. And yeah, I have my script over here. So when I ran the script, I was able to get a ROC curve which shows true positive rate and the false positive rate. And then the average AUC is 0.87. And the confusion matrix here is the T0822. And yeah, so about lab 6p.py, it took time and I I got the value here. Best score is 1. The best parameter C 2.0 something and kernel is linear tall 24.32. And lab 6C I'm going to run. This also takes some time. And I was able to get the value of C10 class weight like I've explained before. I was able to get the same thing. Best score is 0.9531. The best parameter C with 10 value 10, class weight is none, and kernel is body. And that's all. Thank you.